Hello everyone, welcome to Aerospike Digital Summit. I'm S. Panchabakesan. I'm a software engineer. I work as part of the ecosystems engineering team at Aerospike. I'm one of the co-developers behind the Aerospike cloud product and its components. Today I'm going to talk about the Aerospike monitoring solution, which is based on the popular Prometheus and Grafana stack. So let's get started. Let's start with some basics of Aerospike monitoring. The Aerospike database includes instrumentation that provides instantaneous and cumulative metrics for the cluster, which covers the server health, database performance, and its operation. Aerospike exposes these statistics and configurations via info protocol. The info protocol can be accessed by our Aerospike clients and some of the tools. An example of such tool is the ASInfo command line tool. So here you can see an example of fetching node statistics using ASInfo. The Aerospike Prometheus exporter uses Aerospike client, thereby using the info protocol to access the Aerospike cluster metrics and configurations. Now let's take a look at the Aerospike monitoring stack. So here is a nice diagram which represents the high-level architecture of the Aerospike monitoring stack. So we have 5 main components: the Aerospike server node, Aerospike Prometheus exporter, Prometheus, Grafana, and alert manager. So here's how the flow works. So Prometheus makes request for metrics to Aerospike Prometheus exporter. So this happens at a regular interval, which is configurable on Prometheus as scrape interval. On receiving the scrape request, the exporter creates a connection to the Aerospike server node, and it performs an info call requesting the statistics. The Aerospike server node responds back with the results, which contain the metrics and its values. The exporter writes this information into a form which Prometheus can understand, and it sends it back as a response to the scrape request. So once we have the data, metrics data available on Prometheus, it is stored in the time series database. So now Grafana can connect to Prometheus and query these data using PromQL, which is Prometheus query language, and use the returned metrics data to generate visualization. Prometheus can also generate alerts based on certain alert rules, and it can push the alerts to alert manager, and alert manager can then send notifications to third-party applications like PagerDuty, Slack, and Opsgenie. Now let's take a look at a list of features of Aerospike monitoring stack. The Aerospike monitoring stack can be used with both enterprise and community edition Aerospike clusters. It can be deployed as a turnkey solution out of the box, or can be easily integrated into an existing Prometheus Grafana stack. So it's pretty flexible. And the Aerospike monitoring stack includes pre-configured dashboards, and it comes with the default minimum alert rules that can be easily imported into Grafana and Prometheus. So some of the security features include the HTTPS and basic HTTP auth, which will be applicable for traffic coming from Prometheus to the exporter. The exporter supports the Aerospike TLS feature as well, and the Aerospike's access control feature for authentication. The exporter also supports filtering of metrics based on a configured allow list and a block list. So you can select only the metrics which you want to monitor. And yes, so Aerospike monitoring stack is consistent with the database releases, so it's always up to date. So now let's take a look at the most important component of the monitoring stack, which is the Aerospike Prometheus exporter. So the function of Aerospike Prometheus exporter is when a scrape request is received from Prometheus. The Aerospike Prometheus exporter connects to Aerospike server node. It collects the statistics using info requests and sends the metric data back to Prometheus as a response. So here you can find the links for how to install Aerospike Prometheus exporter and how to do the configuration. So now let's take a look at a few examples and go through the configuration of Aerospike Prometheus exporter. So you can specify the IP. So first the configuration is a TOML file. So it follows the TOML file syntax. You can specify the Aerospike IP and port to connect to. You can also specify the Aerospike's access control credentials for authentication against the Aerospike server node. So you can also specify the TLS configurations for connections to Aerospike server node. So it also supports mutual authentication and encrypted key files. You can specify the endpoint for exporter to listen to for connections from Prometheus, and you can add custom labels to metrics. As you can see below, you can also configure the basic HTTP authentication and HTTPS configuration, which will be applicable to the traffic coming from Prometheus. So next, we have one of the cool features of exporter. So you can configure a metric allow list and a block list to filter out the metrics you want to be exported to Prometheus. You can use wildcards and globbing patterns for bulk metrics filtering. This is really useful because sometimes you only need to monitor the metrics which you are interested in. So here is an example for using the metrics block list configuration. Now let's take a look at the Prometheus component. It's an open source time series database and alerting system. You can have a common Prometheus deployment to store metrics from multiple sources. So you can easily integrate the Aerospike monitoring stack into an existing Prometheus deployment. The time series collection happens via pull model over HTTP and HTTPS or HTTPS. The exported targets are discovered via service discovery or static configuration. It has a powerful PromQL query language, which is Prometheus query language, to fetch the metrics data. And here are the links which you can refer on how to install and configure Prometheus. So let's take a quick look at an example Prometheus configuration. So a few things to note here. The scrape interval is set to 15 seconds. This is how frequently the Prometheus will request for metrics from its scrape targets. Next, alerting is enabled. An alert manager endpoint is provided. An alert rule file have been used, which defines the rules to trigger an alert. Lastly, the scrape configs define the exporter targets. Here it contains a static configuration where the endpoints of exporter targets are specified. So this is an example of PromQL query on Prometheus dashboard. The query here is computing overall throughput on the cluster, which includes both reads and writes. So below you can see a few links which you can refer for more details on how to write a PromQL query. Next, let's take a look at the Grafana component. So Grafana is an open source visualization and analytics tool. We can use Grafana to visualize the metrics data from Prometheus. So here are the links which you can refer on how to install and configure Grafana. Now let's take a look at how Grafana can be easily configured for the Aerospike monitoring stack. So first step, you have to add a provisioning config directory in the Grafana configuration file. Create the directories as mentioned here. So two directories inside provisioning directory for database for dashboards and data sources. Another directory, for example, the var lib Grafana dashboards to keep all the dashboard JSON files. Now create an all.yaml file inside dashboards directory to define dashboard provider, and one in data source directory to define Prometheus and alert manager data sources. So next, install the alert manager data source plugin using the Grafana CLI. And finally, you have to import the dashboards provided with Aerospike monitoring stack into the var lib Grafana dashboards directory. You can also import the dashboards directly from the Grafana UI. So here is an example of cluster view dashboard in Aerospike Monitoring Stack. So next, let's take a look at the Alert Manager component. Alert Manager handles alerts sent by Prometheus, which is based on certain alert rules. It can push notifications to third-party applications like Slack, PagerDuty, and Ops Genie. So here are the links on how to install and configure Alert Manager. Next, here is an example of Alert Manager configuration to send alerts to a Slack channel. And below that, you can see an example alert rule defined in a YAML file. So yeah, one thing to note that the rules file should be added and configured on Prometheus. So here is an example of alerts firing as viewed from the Grafana dashboard of Aerospike Monitoring Stack. Next, let's briefly go over the deployment models of Aerospike Prometheus Exporter. So on VM and bare metal servers, Aerospike Prometheus Exporter can be deployed on the same instance as the Aerospike process. It is pretty lightweight and non-resource intensive. And note that you must deploy one exporter per Aerospike node. So on Kubernetes environment, Aerospike Prometheus exporter can be run as a sidecar container alongside the main Aerospike container within a single Kubernetes pod. Here is an example of Prometheus configuration to discover exporter targets on Kubernetes. You can use the Kubernetes SD configs to fetch exporter targets from the Kubernetes API. So in the example shown, Prometheus will be able to discover and add exporter targets in the default Kubernetes namespace, which have the endpoint port name as Aerospike Prometheus exporter. So now let's take a look at a short demo that I've prepared to show how Aerospike Monitoring Stack works and how it can be effectively used to enable monitoring, alerting, do metric analysis and troubleshooting of Aerospike clusters. In this demo, I'm using a Kubernetes environment. I will deploy an Aerospike cluster using the official Aerospike Helm charts. I will also enable the Aerospike monitoring stack to help us monitor the cluster, do metric analysis and troubleshooting. You can find the official Aerospike Helm charts on artifacthub.io. You can find the charts for both community and enterprise edition. So let's get started. First, I'll add the Aerospike Helm repository so that we can access the Aerospike Helm charts. And next, I will deploy the Aerospike cluster. So this is the command that is being executed to deploy my Aerospike cluster on Kubernetes. So you can see I'm using the enterprise edition chart. I'm passing in the feature key file, which is the enterprise license file. I'm enabling the monitoring stack, which includes Prometheus, Grafana, and Alert Manager, all pre-configured. And they'll be running as a stateful set on Kubernetes. And this will also include the Aerospike Prometheus exporter, which will be running as sidecar container alongside the main Aerospike container within the same Kubernetes pod. So next, I'm passing in a custom Aerospike configuration file. Exporter logging level is set to debug. I'm passing a custom Aerospike Alert Manager configuration file, which is configured to send alerts to my Slack channel. I'm also passing in a custom alert rules file, which has a set of alerts defined. I'll show you in a while. And lastly, the credentials for the Grafana UI. So let's quickly take a look at the alert rules file. So I have 3 alert rules defined for this demo. So one is the high watermark breach, one for the namespace top rights, and one to check if the Aerospike or the exporter is down. So let's quickly check the status of all the resources. Yeah, so you can see all these are deployed as a stateful set. And the Prometheus pods are up and running. Grafana pod is up and running. Alert Manager pod is also up and running. And our Aerospike pods are coming up one by one. And here you can see the count is showing up as 2 because this includes the 2 containers within our Aerospike pods. One is the main Aerospike container, and another one is the Aerospike Prometheus exporter sidecar. So let's add some load to our cluster. So I will add a read update load. So I'm running a Kubernetes job, uh, which is running a container based on the Aerospike tools image, and it's running the AS benchmark tool. So let's quickly tail logs. Yeah, so we can see some writes and reads happening on the cluster, and let's make a note of the overall TPS, which is around 35K, and we will now try to verify this on the Prometheus dashboard. So to connect to our Prometheus dashboard, I'm using kubectl port forward command, which will route traffic from my localhost 9090 port to the Prometheus service, which is running on Kubernetes. And similarly, I'll do that for the Grafana service as well, so that we can access both the dashboards from our local host. And now let's access the Prometheus dashboard first. Yeah, so let's take a quick look at the targets, which are the exporter endpoints. All the 3 endpoints look healthy, and the rules, the 3 rules that we have defined. And let's take a quick look at the configuration. So the script configuration is using the Kubernetes service discovery to discover the exporter endpoints, and the alert rules that we have defined is also being passed as a file, and the alerting is enabled. So you can see this is the endpoint for the alert manager service, and the script interval is set to 15 seconds. So let's do an example PromQL query on the Prometheus dashboard. So let's look at the overall TPS. Let's add some labels for our cluster and namespace test, and I will apply rate over it. Now let's copy this and do the same for the write success count. Yeah. So this query will give me the overall TPS, which includes both read and write success count. And here we can see the output is almost 11.77K per node. So if we add this, it will come around 35K, 36K, and that matches with the value that we are seeing in the AS benchmark logs. The overall TPS is around 35K. So that looks good. This is an example of running PromQL queries from the Prometheus dashboard. Now let's take a look at the Grafana dashboard. So the Aerospike Monitoring Stack contains these 6 dashboards. So let me quickly walk through each of them. So the alert dashboard will contain all the active alerts that are firing. And the cluster overview will give you high-level information, high-level status of the cluster. The latency view will show you the latency metrics, so you can look at the latency values for read and write transactions. And the namespace view will show you the namespace level stats. The node overview will show you the general node level statistics. XDR view, if you are using the XDR feature, you can view those XDR metrics on this dashboard. So let's focus on the namespace view. So let me view for last 5 minutes and make the refresh interval a bit aggressive. So currently the cluster contains 250,000 250,000 master objects, and the storage usage is at 47%. Memory usage is at namespace memory usage is at 34%. So now let's do an experiment. I'll try to add more load, add more data to push this cluster to run out of capacity. Yeah, so let's try to add another load. Yeah, so the uh, new benchmark load has started, and the writes are happening fine. And let's quickly look at the Prometheus Grafana dashboard. Yeah, so we can see the object count increasing. The usage is also going up. The high watermark level is set at 60%, so that should cause the high watermark breach to happen now. Yeah, so we can see the high watermark breach state is critical now, and that should trigger an alert to our Slack channel. And okay, so we have also reached the 90%, so that should also trigger the stop writes alert. Let me also open up the cluster view dashboard. Yeah, so we can see the alert count is 6. So yeah, let's go back to namespace state. Yeah, so we can see the alerts coming up on Slack for high watermark breach. And we should also have an alert for the stop writes as well. The storage usage is at currently 94%. Yeah. On the alerts dashboard, we can see these 6 alerts, one on each node. Yeah, so we have all alerts for stop writes as well. Yeah, so we have high watermark breach and namespace stop writes on each Aerospike pod. And yeah, so we ran out of capacity, and our namespace usage is currently storage usage is at currently 94%, and memory usage is at 67%. Now we have ran out of capacity. We should see some errors in the AS benchmark logs. So let's check the logs of our read update load. Yeah, so we can see the errors happening all on writes because namespace is under stop writes and the write TPS is 0. So now let's try to fix this. And so to fix this, I'll just add more capacity to the cluster. I'll scale up uh, the cluster by adding 2 more pods. So I'm setting the cluster size as 5, and I'm using Helm upgrade command to update the release. So now let's monitor from the Grafana dashboard. So we should see things improving. Yeah, so we have migrations getting triggered because we have added a new node. And yeah, let's refresh this. So we have the cluster size as 4, migrations happening, and alert count is still 6. Let's look at namespace view. Yeah, the storage usage has decreased because we added more capacity, so that should go down. And yeah, the stop writes has turned to green. And on the cluster view, the alert count has decreased. We still have migrations happening. The cluster size is now 5. Alert count has gone to 0. The migrations are still happening. That should be fine. And on the namespace view, we can see all the state of stop writes and high watermark breach has gone back to OK, and it looks green. So everything looks good now. Yeah. So migrations are still happening and the storage usage is at currently 60%. So it looks good. And yeah, so this is just a demonstration of how we can uh, effectively use Aerospike Monitoring Stack to set up alerts, to enable monitoring, and do metric analysis and troubleshooting of the Aerospike clusters. Here are some useful links which you can refer for more details and to get started with the Aerospike Monitoring Stack. Aerospike Monitoring Stack is open source, so feel free to provide any feedback, suggestions, or code contributions as GitHub pull requests or issues on these repositories. We have reached the final part of this session, which is Q&A. Thanks for sticking around. I can take some questions now.
So thanks, SP, first for that, covering that very useful topic, it out and having an excellent demo. So this is a Q&A segment, and people should feel free to use the Q&A channel, the chat channel, to submit whatever they want to ask about monitoring. And while you do that, I have a few questions of my own that I'll ask SP. So we have about 5 minutes, and so we'll try to get some more information out. So the first question is about the system metrics. It's a great tool and pipeline to collect metrics. What are the metrics that you can monitor? Can you also include system metrics?
Okay. So the metrics that we can monitor from Aerospike Monitoring Stack is we have the namespace level statistics, the set level statistics. You can also monitor the node level statistics. We have metrics for the latency and the XDR stats as well. But yeah, if the question is related to the system level statistics, then by default, the Aerospike monitors the CPU and memory level stats. So if you want to monitor something outside of this scope, then you might want to check out a node exporter, which is developed by the Prometheus community. So yeah, that has to be deployed along with the Aerospike Prometheus exporter on the Aerospike host. So that will help you collect the system level statistics like the contract, the bonding interfaces, and the netstat kind of stuff. But yeah, I would recommend to deploy the Aerospike Prometheus exporter first and look at all the metrics that are available. And if you still want to go ahead and look at certain system level stats, which is outside the scope of the exporter, so yeah, so you can go ahead and deploy the node exporter. But yeah, and also like if you feel that some of the stats can be monitored through the exporter, so feel free to provide any feedback and submit your feature request. So we will definitely consider it.
Great. So I think the second question is also, I think, along the same lines, using one Prometheus to collect, metrics from different systems. So the second question is kind of, similar answer probably, can you monitor metrics from different Aerospike clusters in the same instance?
Yeah. Yeah. So you can definitely monitor multiple Aerospike clusters with a single Prometheus Grafana stack. So what I would recommend is you have to set a configuration called cluster name. So if you set that for each node belonging to a certain cluster, so that will help you filter out a specific cluster on Prometheus. So the way it works is the value of the cluster name configuration will be set as a label to each metric. So when you're querying from Prometheus, or when you're using PromQL query language, so that time you can add that label for the cluster that you want to monitor.
Great. And I think the next area is probably a separate session almost. How do you use all this information to troubleshoot? So can you sort of, we have about 2 minutes left. So, brief view of, on that topic.
Yeah. So definitely, the first thing is you can, like if you want to troubleshoot, first thing to check is the Prometheus logs. so you can know if the scrape is happening successfully. And the next level, if you think the Prometheus logs are looking good, then you can go ahead and look at the exporter logs. So exporter has debug level logs and trace level logging. So that should definitely give you an indication of where the problem is, if there are any issues. And if everything looks good, yeah, finally you have to go ahead and check the Aerospike server logs.
Great. So I think quickly, if you can answer, how do you filter out metrics that you want to monitor? I think you probably covered it, but yeah.
Yeah, I think that's a good question. So by default, all the metrics are exported from the Aerospike server node. So some of the metrics you may not want, and even if you have huge amount of metrics being sent to Prometheus, then that can lead to a huge time series. The exporter supports two configurations. One is called allow list and a block list. Another one is the block list configuration. So you can use this configuration to select the metrics that you want. And each of these configurations supports the globbing patterns, kind of rejects, which will help you to select a good amount of metrics which have a similar name. So you can use globbing patterns to allow bulk amount of metrics, and later you can also use a block list to filter to remove the metrics that you don't want from that allow list.
Great. I think we are at the end of the session time. So I'd like to thank SP for such an informative session, and for all the audience for attending this session. So thank you all.
Yeah, thanks everyone for attending the session. And if you still have some questions, you can post it on GitHub. So I'll be able to answer questions there. Thanks.